We are having a fun day here at the Edgerton. Always some good laughs to be had when we are experimenting and trying new things. Forgot my faithful goggles. All of them.
We want to make
this
sure.
Is Nicole's pair.
Oh.
That's Nicole's pair. That won't work. Blue.
Blue. Incoming.
Learning should always be fun, and we're going to have some fun with some circuits today. And so what we have for you today in front of you is a couple different examples of circuits. So some are complex, some are fruity, some are simple.
And electrifying, huh?
And electrifying.
Hey, hi, Marcy.
One of the things that we need to discuss is making a complete circuit so that energy typically wants to flow in a circle, especially with a direct current circuit. So that's why your batteries are called DC, is direct current, and that current is flowing from one point to another point. This little energy stick that I have in front of me has little batteries in the end, so they're DC, and the tape on the end is metallic. And so one end is positive and the other end is negative. But nothing is completing this circuit because there's a negative end and a positive end, but they don't connect. But when I put my hands on both ends, it lights up and it makes a noise. I, as the human body, am completing the circuit because we have water in our bodies, but not only water, we have different electrons going through us, and they're able to travel through the electrolytes that are in our body, the minerals and those completing the circuit. So the battery power is technically going from my one finger where the battery is on the end, traveling through my whole body and coming out my fingers on the other end. So this is one of the fun things we have on our Edgerton on the Move when we go and visit schools and organizations. This is more of the same here. We have a battery on this end, a metal conductor on this end, and if I touch both metal parts, then the current is going through me and illuminating our light stick here. And it is fun to see. We do this at a lot of different events, is we see how many people we can get to grab a hold of the light stick or the little energy sticks to see if we can create a circuit. So my other fellow mad scientists are going to join me. I hope everybody can see. So once we complete a circuit through all of us, then if somebody lets go, the circuit is broken and the energy can no longer travel through our bodies. So the human body is quite amazing in the fact that we do have electricity flowing through us. That's what powers our muscles and fires like that. And what creates those circuits, because we do conduct electricity, so we have to be careful around electricity so we don't disrupt the energy that our body puts out. So one of the other things we talked about, we have a fruity circuit here in front of us. We have a bunch of lemons. We have a nail sticking in one end and a penny in the other as our conductors. They're touching the lemon juice in the inside, and the electricity for this circuit is traveling through the lemons and causing our little LED to light up. Now with this circuit, it's using those lemons as a conductor to go through and do that. You can make lemon batteries, you can make potato batteries, other things. It's whether or not there is enough of the right liquid, or conductive material rather, for that electricity flow through that fruit or vegetable that you have. And we have the little LEDs and the alligator clips. One of the fun experiments that we do with our students when we go and do labs for people is called flashlights or LED flowers, depending on how we dress them up is what we call them. And so what it is basically a big craft stick or a tongue depressor. It has a little tiny LED at the top, and then we have this conductive tape that we apply to the tongue depressor, and it is metallic, but it is also sticky. So it's not like Scotch tape or duct tape that looks like it's metallic. This is actually a very thin layer of metal on our popsicle stick. And then we have a little metal binder clip at the bottom and a battery. So the battery is putting its power out. It's going through the conductive tape to the little LED and back down. But our circuit right now is not complete until we flip up our little binder clip, and then the energy is traveling all the way around and completing the circuit. And like I said, we sometimes put a little flower head on it so it looks like a little light up flower or a flashlight, creating a very simple and direct circuit on our popsicle stick.
One of the nice things with that one is we use the conductive tape for the ease of making those, but you can also just use tin foil. You have to tape it down, but tin foil works just as well.
Right. Whew. Our light's going out. So we have our last circuit that's on the table today is a bit more of a complex circuit that we have. So we have a couple of things going on the circuit. We actually have something that looks like an old-fashioned pencil sharpener, but it is actually a little hand crank generator. And when that turns, it creates the electricity that will then flow through our components on our board. And we have little switches that we can then dictate which direction the current goes to and through. And it creates a complete circuit. If none of them are open, that's okay. We're not creating any problems. But we'll just close the one right now for our fan. And as we turn our generator, it's sending out the electricity, and we have a complete circuit because this switch is closed, and that's causing our fan to go. Now I can flip one more of our switches, and it will cause, if I turn fast enough, our light bulb to light up. Light bulbs with filaments do take a lot of energy, so I have to crank even faster to see the filament to actually even just glow. And the last thing on our circuit is a bell, everybody's favorite thing to hear. And so you can manipulate which things are on, which things are off. And as all teachers and adults would love for the bell not to be on there, but it's a very good practical demonstration of that current turning into physical energy to be able to strike and ring that bell. Now our last thing that we have for us, are we going to bring it over this way, Nicole? Or we're going to come over to you?
Might actually have to come to me unless we can actually try and use the extension cord. Computer's a little low.
Then we can put it up here on the table?
Yeah.
Okay.
That's long enough. All right.
So we hope you all had a nice Memorial Day weekend. A little bit rainy for some, so we're enjoying some sunshine now.
Okay, fine. We'll just deal with it. Come on.
This little setup is called Makey Makey program, and
Sorry, old computer.
slow. Well, it hasn't been on for a while. That's part of the problem. So what we did initially is a piano, keyboard,
There we go. Okay. Woo. Like that?
All right, let's see.
Yeah. All right.
All right, I think we can see it.
So we have a little circuit board here that is very smart. It tells the computer what to do. And then we have our makeshift homemade keyboard in front of us as well. And so in order to complete the circuit, we're going to touch the bass pad and then whatever key we want on the piano. Now I am not much musically inclined, so I'm not going to play you a tune, but I am completing the circuit by touching the metal contact here, and then the ones that are laid out on the keyboard in front of us to be able to play the song or play the keys on the computer.
So if you were to just touch the keyboard, nothing happens. All right, so remember, to complete the circle, he has to have a true connection. So remember, it's going through his body to make the complete circuit.
Similar to the energy sticks. We've also done this particular one instead of using a keyboard that we created, but with fruit. We had a one fruit that you had to keep your hand on, and then each key was a different fruit. Again, since electricity can pass through them due to liquid and other things, you complete a circuit.
So with that, we also have other exhibits that are in our zone that are snap circuits, things like that, that you are able to play with and experiment with. And so when we are back open to the public, we hope that you join us and are able to use some of our circuits. Circuits are all around us. They're in our computers, they're in our lights, they're in our phones, they're on our walls, they're in our cars, our automobiles. All those things, there's lots of different circuits out there used in many, many different ways. These are a couple of the different labs that we do have here at the Edgerton. So if we're able to come out and visit your school, if your school books us to do a lab, that might be something that you could consider us doing. And maybe you find your own experiment that you're going to make your own simple circuit. Little LEDs are out in flashlights or available at hobby stores too, that you could play with a battery and completing a circuit like that when you're able to make a different connection between one piece of metal or conductive material and another.
Now, like all of our things that we've done, if you have any questions, please feel free to contact us at the Edgerton Explore Center, and we would gladly give you the information on how to make something, or if you just have questions on how it's working, feel free to give us that call or email us. We can sure like to share our ideas with you.
Okay, anything else from Nicole or Deb today?
Just as things are beginning to open up slowly, we are still closed, so if you want to know when we open again, please keep an eye on both our website and our Facebook page, as those will probably be the things we update first. when we do reopen. But like I said, right now we are still closed. So,
We are also looking to still hold our camps. We have to make some revisions to sizes and other precautions, but pay attention to, like Nicole said, our website or Facebook. You can send one of us mad scientists an email, or even just give us a call, and we would be glad to tell you when we have concrete plans made, what those are going to look like, what camps are going to be when, and all of the details that we can. So thanks for joining us with Let's Explore It today, and I hope you have fun creating something today.